Okay, good. So, hello everybody and welcome to my talk about the dependency inversion. My name is George, and here are a couple of bullet points about me and my previous experience. I work at a top 1 blockchain startup in Israel. I'm a veteran subject matter expert 2023 and 2024 at Coursera. Was leading a backend in the first blockchain-based social network in London, and nowadays I'm working at the TechSpacks. Also, I've attached my the QR code to my LinkedIn, so you're all very much welcome to connect to me. So today's agenda gonna be this. First of all, we'll talk about the problem, then we'll discover a bit about the dependency inversion, talk how to inject the dependencies, we'll discover testing, and quickly go through the anti-patterns. And after that, we'll have enough time for questions. So basically, the problem. Imagine if in your organization you have a payment service that is dependent on a PayPal payment provider. Have anybody ever worked with the PayPal as a provider? Yeah, I see a couple of people, but still not everybody. But I think that even though you never worked with the PayPal, you definitely was a client of a PayPal. So, but in real life, you usually have like a couple of services. So let's now discover if we have 3 of them: order service, subscription service, and cashback service. All of them is dependent on PayPal. And each of them now have its own implementation of working with the PayPal. So it's back, fine. Its own implementation of working with the PayPal's payment provider. But what happens if your business team will decide to switch from PayPal to the Stripe, for example? Then you will have to change the entire implementation of your working with the PayPal to the Stripe one. It's gonna look different, and basically it's like repeating the same work 3 times for each services. But things get even worse when your company is moving to the another market. For example, to the Russian market, when we have lots of region-specific restrictions and you are not able to legally use PayPal or Stripe as payment provider. You have to use the local payment providers as Mir, for example, and now you need to not only implement the entire logic of working with the payments with all these 3 services, but also manage 2 copies of all these 3 services. How to deal with all of this? Here's when the dependency inversion comes to the scene. Dependency inversion is basically one of the 5 primary pillars of Dependency inversion is one of the 5 solid principles, the 5 primary pillars of modern object-oriented software development. So basically, dependency inversion was explained by Robert Martin in 1 sentence. Is basically high-level models should not depend on low-level models, but should depend on abstractions. But what does it mean in real life? Previously, if you remember, we had a couple of services that was dependent on a PayPal. Now imagine when you have one of your services which is not dependent on a PayPal, but now it depends on a payment processor interface. And then PayPal, same service provider, would just realize this interface, would be a realization of, or implementation of this abstraction. In real code, it would look like this. You will define a payment processor interface with only one abstract method process payment, and then when you will make a PayPal struct that will contain an implementation of this methods, you will be able to hide all the work with PayPal under the hood and work with the process payments basically without knowing any details about the implementation. Same can be done with the Stripe. This screen is not showing us the Stripe, but it's definitely very much same with the PayPal. So it's a realization of the methods. It has its own details in the process payments, but we don't really have to know anything about it. But now we have 2 instances that implement our interface, but how can we now use them? For this, we'll need the dependency injection. So now we have to inject these dependencies at the place where previously was an abstraction, our interface. In the Golang, usually we use dependency injection just through the constructor. Have anybody ever worked with the constructor pattern? Yeah, almost everyone. So in a Golang, it usually looks like a new method, and this new method returns us a payment service as a structure, as a pointer to the structure that we just created. So our new method will just accept the abstraction and then save it in one of the payment service fields. And then, when we will need to invoke the payment method logic, we will just use a process payment method from an abstraction from the processor that's currently contained inside of the payment service structure. And in the main file, the work example would look like this. So we will create the PayPal payment provider structure instance, then provide it through the new methods, and would be able to call pay method from this structure. And then, if your business will decide to move from a PayPal to the Stripe, you would be able to implement same logic for the Stripe and use it in the very same place, in the very same way. And now from the main file, from the main control point of your application or any other high-level models, you don't really need to know anything about the details of the implementation with working with the PayPal or Stripe. You will just call an abstract methods pay and then process payment. So now, as you can see, high-level models are not dependent on the low-level models anymore. Both are depending on an abstraction. Testing. Testing is one of the most common cases for using dependency inversion. Imagine an example when you want to cover with unit tests your payment processor service, but you don't really want to transfer any money in the payment environment, in the testing environments. So you just mock in this logic, and then you are able to test the payment processor without transferring real money with Stripe or PayPal. Anti-patterns. Well, the first and the most, let's say, popular in a bad sense anti-pattern is control freak. Control freak is mainly about that we don't really. It's when we don't really creating a structure with our provided abstraction, but we hard code the implementation of the abstraction that's going to be used in our payment service. So now we have no dependencies are injected, class members are initiated directly, and we have definitely no benefits from using abstractions. That's an anti-pattern. Next anti-pattern would be bastard injection. It's a bit different from control freak because it's not directly hard-coding the implementation that's going to be used instead of the abstraction, but it's basically about defining a default parameters for our abstraction. So here you can see that if our processor equal nil, we'll use PayPal as our primary payment processor. Do you have any guesses how can it be fixed? How can we check in the constructor that our processor is nil or not, and in the same time not define any default parameters? So the best solution would be just to return an error, and once the screen will be turned on again. Yeah, now you will see. So we will just check that processor is not equaling, if it's equal nil, we will return an error. Payment processor is not defined. So that's a good solution to fix the bastard injection. Here are also lots of other anti-patterns, such for example fed class. It's when you have too much arguments passing through your constructor, which you don't really use, but it's more about single responsibility principle than about dependency inversion, so I won't go too deep in this today. Now, questions. Yes, please.
Question. I will come actually two of them. Are you in general familiar with Spring Framework, which exists in Java ecosystem?
A little bit. I worked with it like 4 years ago.
So when can we get kind of the basic bean injection implemented in Golang, the same way has been done in JVM like already for years?
So the question is?
Sorry?
Could you please repeat the question?
The question is, do you see anybody creating kind of similar type of the framework?
Well,
bean injections in Golang.
I got your questions. Well, honestly, when I was searching for for the materials for this presentation, I saw such a pattern. It's basically the entire like work with Spring Beans in Bean in the Spring Boot in the Spring applications called locator anti-pattern or a pattern. But in the Golang community, I saw that it's usually desired as anti-pattern. So because you don't have any sort of like a direct and clear connections, which implementation going to be used in this specific place instead of the abstraction, and so on and so on. It's all defined in some like configs at the site, and in the Golang community is usually desired as anti-pattern. That's a very holy war topic, so I didn't include it into my presentation. That's like locator is pattern or anti-pattern, but well, currently I saw that, for example, Facebook Go injection using this. But this like Facebook Go injections was archived at the GitHub around like 2 years ago. So I think that's even they decided that it's an anti-pattern.
Okay, thank you.
I have a comment. So you mentioned that there is a solid principle. There is another principle called KISS.
Keep it simple.
Super. Yeah, so I think Go follows this path. So
Definitely. The entire philosophy under the Golang is about simplicity. So I think you never will see big frameworks such Spring in the Golang, and honestly, very much hope that it's gonna be true. we won't ever see the big frameworks, but so far I very much like this simplicity, and that's basically the primary reason why I fall in love into the Golang. Any more questions? Please.
When I try to do this in Go, I always have the problem that when I have more than 10 dependencies to inject or use, it becomes a bit messy. How do you manage large amounts of dependencies?
So the question is about how to solve this situation?
Yeah, like if
basically.
now you have one example,
Mhm.
if you like go to 10, 15 dependencies to inject.
I get it. Well, the entire answer is going to be just follow the single responsibility principle, and I think that it's going to definitely help. So if your class or function or whatever it is serving only one function, same going to be for your like controller. That's in my example was a main file, and in the controller you're going to manage like only dependencies without any other logic. It's going to start being very simple to manage all of them. So the answer would be just single responsibility. Please.
You mentioned like 10 or more dependencies. Imagine you have 50. Do you recommend any frameworks or anything to work that? Have you ever experienced like why?
Well, if you have to inject 50 dependencies in your one project, I would definitely recommend to just split it to different repos. Because it's like too huge already to be like only one microservice or whatever it is. Yes, but from the frameworks, I think the Facebook Go inject gonna help you, but still it's using like locator, and basically it's giving you the opportunity to simply manage 50 dependencies, but the approach which is used to basically bring simplicity to this is hiding this all the injection logic under the hood, and that's what is basically locator pattern about, and that's what I personally won't recommend to do. Any more? Please.
How do you deal with the errors if one of your implementations returns like a set of typed errors from like a function implementation, then you're slotting in something else? How do you keep the typed errors working between
So if I got your question right, you have like a couple of errors. They are distributing between different services. Well, all the errors are very much unified in the Golang. We have like only the error type itself, and if you want to customize somehow your error, there are like lots of other mechanisms like ROPs of errors and so on, so on. So I would definitely recommend to use unified type error for all your dependencies and so on, so on. And well, you will need to like figure out which class was used, which error was returned back to you, like which type or whatever. You will use just method is from errors package, and before this ROP to ROP one error into another level. So in the end, you will have like low-level error wrapped with the middle-level layer, wrapped with the high-level model, and then each of them gonna be retrieved from the errors is method. And through this, you will be able to go through all the stacks of your errors. Any more? Thanks, guys. And I want to finish my presentation with the quote from the Robert Martin about that, of course, bad code can be cleaned up, but it's always very expensive. Thank you very much.